period class. This is the chapter review. I'm videotaping this from 6th period. Chapter review or semester review, I should say. Chapters 5 through whatever we just got done doing. Mixed review, I guess. There are 46 questions in this entire packet. Your semester test will be 46 questions. Of those, you have to answer 40 of them. So you get 6 freebies. Okay? If you answer all 46 questions, I just take 6 of them if they're wrong, and you get basically 6 free, all right? Same rules apply as what it was in December, but there's 46 questions. You have to answer 40 of them. We will fill this packet out together. I may assign some homework for tomorrow and such. Assign these problems that you need to have done, whatever. But we will do this review packet together. Anything that I write down, you should also write down. I will not only answer these questions, but I'll write any notes that you need. And you can use this packet on your test. Anything I forgot to say? No? That's it? Okay, so do you want to start from the back and work to the front, or start from the front and work to the back?
From the back, back to the front. Back to back. My brain just learned new stuff. Back to front because we learned this stuff and then we can work in hard and do the harder stuff.
Back to front?
Yeah.
And then I'll help you with stuff later. Okay, let's go back to front. All right. So let's start with, I'm going to start at the top of the back page. So we won't work all the way back to front, but we'll start at the top page. We'll do the back page first, okay? So starting with the mixed review first, we're going to start with number 40. So this is like way at the beginning stuff. This is like the important stuff that I want you to make sure that you remember, okay? So that's why I'm putting this on this test. We've done this since December, but we learned it the first time in probably first semester. But these are things that you really need to know. Yes? Yes, I'll give you all that stuff that you need to use. Okay? So, number 40, write the equation of a line in slope-intercept form that passes through those 2 points. What is slope-intercept form, by the way?
X squared X.
And X.
I forgot it.
Y equals MX plus B.
Y equals mx plus b. Okay? Now, how do you find the slope? Yep.
Y2 minus Y1 over X2 minus X1.
Exactly. Y2 minus Y1 over X2 minus X1. So, of these 2 coordinates, what I need to do is I need to find my M first. Okay? So, what is your second Y coordinate? 9 minus 6. And the second X coordinate? 3 minus 2. So, 9 minus 6 is 3. 3 minus 2 is 1. So, my slope is 3. Okay, now what?
Y equals 3. Plug in an X and Y in the B.
Yep, so now we need to solve for B. After we found the Y, we need to find the B next, okay? And so I'm going to plug in to solve for B. What do I plug in? 2, 6, or 3, 9? It does not matter which one you plug in. So which one do you want? 3, 9? Sure. So Y is the 9 and 3 is the 3. I feel like I'm shouting into this thing. Make sure that you don't flip those 2 around, okay? Just because the Y comes first, you still put the 9 first, okay? Plus B. This is 9. So how do I find B? Subtract 9 from both sides, so that cancels them out. So then what is B? B is 0. So my equation is Y equals 3x plus 0, or you could just write Y equals 3x, because the plus 0 means nothing. So either way you put it, it will be correct. Yeah? You remember doing that a long time ago?
Yeah.
Those should be free points to you. You want to answer those, and you want to make sure you get those right. But those are really important questions. Those show up all the time on the ACT. They will ask you those questions like that. Like, find the slope between these 2 points. There you go. Okay? So I want to make sure that you know how to do that. All right. Write the equation of a line that is parallel to this one. This is in slope-intercept form already. Okay? And what is true about lines that are parallel? They have the same slope. Okay, what about perpendicular lines? They have the negative reciprocal slope. Okay, so this one's asking for parallel, and the slope here is 3 over 2, right? So what do I do with the 9 then? Caleb's doing a waving motion like get rid of that thing. Right? You cross it out because the 9 means nothing. So we're going to keep the 3 over 2, but we're going to get rid of the 9. So we have Y equals 3 over 2 X plus B. We're going to name it B, and then we're going to plug in, right? Okay? So plug in. 4 goes in the X, negative 2 goes in the Y. right? This is like 4 over 1, so I cross out. This is 2 and 1. So what's this middle piece right here? 6. So I've got negative 2 equals 6 plus b. And then minus 6 minus 6, so this is negative 8 equals b. And then my equation is y equals? Yep, 3 over 2x plus negative 8, or I'm just going to do minus 8. Okay? Now, if that was asking for a perpendicular function, it is not, but if it was, what slope would you use? Negative 2/3. So 3 over 2 would become negative 2/3. So on the test, it might be perpendicular instead of parallel, so be careful with that. Okay? Good? Okay. Everything else should be in the music room. Okay? All right, 42. Solve using any method. What are the methods that you can use? Substitute or eliminate, right? This goes up there. You can substitute or eliminate. Okay, which one would you rather do for 42? It doesn't matter.
Substitute.
You would rather substitute? Okay, when you substitute, you have to get one of the variables by itself. Y, which y would you like to get by itself? The top one. So let's bump this y from here over to here. Okay, so 4x is going to stay in the same spot, but the y is going to become positive. Okay, that's really nice. 4x is equal to y. Then what do I do?
Plug in.
This 4x is going to go in right here. Okay, so 6x minus 3 times 4x equals 12. Yeah?
Mhm.
Now, I did that so that now I'm only dealing with x's, right? Okay, so this is 6x minus 12x equals 12. What's 6x minus 12x? Negative 6x equals 12. Then, divide by negative 6. I'm running out of room. X equals negative 2. Negative 2. Okay, done? No, now what?
Plug in.
Plug back in where? It doesn't matter, but the easiest place to plug back into is 4x equals y, right? So 4 times x, which is negative 2, equals y. Y equals negative 8. Okay? And then I like to write my answer like this. Okay? Why do we write our answer like that? Those coordinate points. What's special about that coordinate point? Not intercepts the x-axis. Nah. What? No? No? These two functions right here, if you graph them, what do they look like? No? Those are lines. Those are straight lines. So what happens at this point?
That's what they intersect.
They intersect each other. So they're crossing each other at the point negative 2, negative 8. Exactly. That's where they cross each other. Yeah? What?
That's what I said the first time.
Oh, I thought I heard somebody say x-intercept. I'm sorry. So yes, that's where they intersect each other. Yes. I thought I heard x-intercept. But yes, that's where they intersect each other. Yes. All right, now we get factoring stuff. There are three factoring problems that I put up on there. There's really 4, but I leave off the greatest common factor. So you have the other 3. We have a difference of squares, a simple trinomial, a complex trinomial. What one is 43?
Well, that's a square.
Difference of squares. That's a difference of squares, okay? Now, can you take the square root of x squared? Can you take the square root of 64? Okay, so you're going to write them as 2 pieces like this. The square root of x squared is x. The square root of 64 is 8. And what goes in between them? Plus and minus. Okay, now, since I have it set equal to 0, we're going to set those equal to 0, right? If x plus 8 equals 0, and I subtract 8 from both sides, x is equal to negative 8, right? Okay, some of you guys just know that, right? If you set that equal to 0, it's just the opposite, okay? But it's for this reason. If x minus 8 equals 0, then you add 8 to both sides, and x is equal to positive 8, right? Those are my 2 answers. Yeah? Solve that by factoring. Okay? Good? Yes? All right, 44. What is that? What kind is that?
That is
The
simple trinomial.
Yep, that is a simple trinomial. Simple trinomial, okay? Simple trinomials are nice because you can just break them down. Okay, what do you ask yourself?
What? No.
Multiply
What times
goes
what gives
into
you
8.
that?
What and add to
What
so
multiplies
Multiply to get negative 8, add to get negative 7. Exactly. Multiply to get negative 8, add to get negative 7. What are they? X goes here and here. Okay, what are you multiplying to get 8, add to get negative 7?
Negative 7. Yeah.
Negative
Negative
8
1.
and 1.
Wait, negative 1. Negative 8.
Negative 8, whoop, positive 1. Negative 8, positive 1. Let's check. Negative 8 times 1 is negative 8. Negative 8 plus 1, negative 7. Good. Okay, now if I set those equal to 0, if I set x minus 8 equal to 0, what is x equal to? Positive 8, right? Do I have to write the work out?
No.
No? You understand why that is?
Yeah.
If x plus 1 is equal to 0, what's x equal to?
Negative 1.
Negative 1. Those are my two answers that I get. Yeah? Yeah? Yeah?
Can we
Yeah.
do a GCF like on the side?
What?
Can we do a GCF?
You want to do a GCF?
Yeah, just.
It won't be on our test.
Is that going
I don't think so. I don't think so.
I don't think so.
Well, here's what I would do, Maddie.
Fine, but we're
Here's how I would change this, okay? Let's say in number 44, so Maddie's asking for a GCF because I said it wasn't going to be included. What if I would do this instead? 2x squared minus 14x minus 16. Okay? I took that same problem, but I multiplied it by 2. Okay, so first, that looks like a complex trinomial, but it's actually not. I can take out a 2. And then I treat it like that simple trinomial that we just did. Okay, and I can divide by 2 on both sides because I get rid of it, and then I'm back to where I was before, right?
So what
Okay.
about number 45? Because you can divide by
Oh man, you can. Shoot, that is a simple trinomial.
What?
I didn't even put a complex trinomial on there. What?
So wouldn't that be a great
What?
common factor?
Yeah, that is technically a greatest common factor. What?
Wow. So now we
Um, I gotta think. 3, 4, yeah. Do you want to do it by complex trinomial, or do you want to do it by greatest common factor and pull out in simple
So
trinomial?
we should go out on a GCF and then we should do
Or we can do it
complex
both
on the
ways.
side.
Let's do this one as a complex trinomial because I don't know what the one on your test is like. So let's do this one by complex trinomial. What do you do first? I'll write it off to the side. Complex
Multiply 2 and 6.
trinomial. Yes. Multiply 2 and 6 together. 2 times 6 makes 12. Okay? Complex trinomial. We're factoring this by a complex trinomial. They said that you should be able to just divide everything by 2, but we're going to pretend that you can't do that and factor it this way. Okay? So, that is 12.
2 and 6.
45. 2 and 6 make 8. You multiply to get 12, but when you add them, give you 8. So, then what?
X.
2x squared plus 2x plus 6x plus 6. These two stay in the same spot, but this 8 breaks down into those two pieces, yeah? Okay, now, what do I do? This is also like Cody's method is what we called it. What? Now we, yep, it's factor by grouping. Group, group. Okay, what comes out of the first piece?
2x.
2x, okay, and left over is x plus 1. And what comes out of the second piece?
6.
6, and left over is x plus 1. Right? Yeah? Caleb's confused?
No, I'm not. I just see points. That's what I
Okay.
said.
Okay. All right, so this one, 2x and 6 are pulled out. X plus 1 is what we have left over in the inside, and we know we did it right because those are the same. And then 2x plus 6 is here. Okay? All right? Then what? Set them equal to 0. So if x plus 1 equals 0, x is equal to negative 1. What about 2x plus 6 equal to 0? We might actually have to do that. Plus 6 equals 0. Minus 6 minus 6. 2x equals negative 6, so x is negative 3. Yeah? Okay, do you want to see it if I do it as a factor by grouping and simple trinomial?
Not really.
Not really? You're going to get the same answers if you do a complex trinomial instead, or a simple trinomial instead. Okay, good. Moving on. So those are stuff that you will see forever and ever and ever in the rest of your math classes. Like forever. Even in geometry next year, you'll see those. Geometry has a lot less algebra than this class does, but you'll see those in geometry a lot. Okay? All right, 46. 46. You must write stuff out or you will get it wrong. Because I can't do this in my head. You guys have to write it out. Separate them into 3 pieces. The square root of 24, the square root of x to the 3rd power, and the square root of y to the 9th power. Okay, those 3 pieces. Okay, now we break down. So what can we pull out of 24 that you can take the perfect square root of? 6 and 4? Yep, so I'll put 4 in this box and we'll put 6 here, right? I don't think those break down any more than that. So the square root of 4 is 2, and the square root of 6 stays, right? Okay, and we do that. That one's done. Now we're going to do the x's and then do the y's, and then we're going to shove them all back together. So the x's, what can you pull out of the x's that you can take the perfect square root of? X squared and x to the 1st power, because those together make 3, right? So what is the square root of x squared? X and the square root of x? Yep, x square roots of x, yep. Okay, what about y to the 9th power? Nope, you're not taking the square root of 9.
Y
X squared and X.
Yep, x squared and x to the 1st, yep.
Y to the 9.
Isn't it y to the 9?
Because is there something that you can take times itself to get y to the 9? Like you guys are saying, take the square root of 9, so that's 3. What about y cubed and y cubed? If you multiply those together, what do you get? Not y to the 9. That's y to the 6. That's not going to work.
So y to the 3rd and y to the 4th and y to the 3rd.
Y to the 7th.
Y to the 4th.
Wait, why does it? Why
Huge
does
debate.
Y to the 4th and y to the 5th.
When you're doing these, you only ever hang off 1. Right? You only have an extra 1. Is that what you said? Kelsey, I just can't hear you. You only ever hang off 1. Right? What times itself will give me y to the 8th? Or, yeah, y to the 8th. What times itself will give me y to the 8th?
Only have 1. Y to the 4th and y to the 4th.
Y to the 4th and the square root of y. You will only ever hang off 1 y. Does that make sense? Or 1 x. No matter how big it is, because you want this to always be an even number. So you only ever hang off 1, if at all, right? You're confused. What you confused about? Okay? Y to the 4th times y to the 4th is y to the 8th, right? I want this to be an even number. Yeah? So then I hang off 1 y, so these two added together make 9. And this, when I take the square root of y to the 8th power, is y to the 4th. Right? It's just half of it. Okay, so don't think of it as being like the square root of 8. That's not how exponents work. It's not the square root of 8. Like we just said, the square root of 9 is 3 and 3, but that doesn't multiply together to make y to the 9th again, right? So when you're taking the square root of an exponent, you're dividing it in 2. Right? Okay? So there's that. Now slam them all back together. What do we get? 2. X. Y to the 4th. Square root. Yeah, that's a lot. You cannot do that in your head. I can't do that in my head. Do them all separate and put them back together. Yeah? You don't have to put quite as big of a space as I did. But there you go. Okay, good? All right. Still working backwards? Should we start with trigonometry at the top? 33?
Can we do 4 classes? Can we do one of the graphing?
Sure. Sure. Yep. So let's start with 33. We'll see if we can get this page all the way done, and then we'll stop for today, okay? All right, find the value of sine, cosine, and tangent for theta. Okay, so in order to do this, I have to do something first. I have to find this guy right here. I don't know what he is. Okay? How do I find him? A squared plus b squared equals c squared. Okay, which one has to be your side C? 30, the hypotenuse, okay? So let's call this guy A and let's call this guy B. So we've got 24 squared plus b squared equals 30 squared. 24 squared, I don't know that. 676. 576, okay. Plus b squared equals, that one you should know, 900, right? Okay, then Subtract 576. 324. Does that come out as a perfect square root? Please, please, please. What? 18. Man, that's awesome. 18 right there. Okay, now we want to, now that we found that, we want to find sine of angle theta, cosine of angle theta, and tangent of angle theta. Just those three. Okay? And to do that, we have to use SOHCAHTOA. SOHCAHTOA. Okay, now, one more thing I want to do before I write these in here. 30, 24, and 18 will all reduce. So rather than putting them over here as the fractions and then having to reduce them there 3 different times, let's go ahead and just reduce them here on the triangle. So what number will go into all 3 of those numbers? 30, 24, and 18. 6. 6 is a bigger number. Yep, let's do 6. So 18 divided by 6 is 3. 24 divided by 6 is 4. 30 divided by 6 is 5. That is a 3, 4, 5 right triangle. You geometry kids, which is just Liddell in here, I think. 3, 4, 5 is a special right triangle. There's a lot more of you in 8th period. So 3, 4, 5. Okay, so sine of theta. Theta is in this spot. Okay, not up here, so you're looking at just this one. Sine is opposite over hypotenuse. Okay, what's opposite of angle theta? 3. So 3 over the hypotenuse is 5. So that is 3/5. Okay. Cosine is the adjacent side. Adjacent means right next to. 4 over 5. Okay. Tangent is opposite over adjacent. Opposite is 3. Adjacent is 4. So 3 over 4. And that is all. I want those 3. This is what you need for your answer. Okay. Okay, so 34. Solve this triangle for x is what we're trying to find. Okay. Now this is a right triangle, so I should still be able to use SOHCAHTOA, right? Okay, but we have to figure out which one we're going to use, because we're not going to use all 3, we're going to use one of them. Okay, so 64 degrees is the angle. I always start with the angle, right? What is x in relationship to 64? What? Opposite?
Oh, yeah, that's what.
And 11 is? There's your adjacent. Opposite adjacent. Okay, so which one uses opposite adjacent? O and A. Tangent. So I do tangent of 64 equals, opposite is x, adjacent is 11. Okay, and then what? Nope, not yet. Multiply by 11 on both sides. So x is by itself now. And we have 11 times tangent of 64, and that's what x is. 22.55. Perfect. That looks good. Okay? Now, look back at your triangle and make sure that that seems reasonable. Okay? If this is 64 and this is 90, what would this angle right here be? Smaller, maybe? Right? All of them have to add up to be 180. Or really, if this is 90, then these two have to add up to be the other 90, right? So what plus 64 will give me 90? 26. So this is a 26-degree angle. 26 is opposite from 11, right? 64 is opposite from the angle that we just found. So what we just found should be bigger than 11, right? Because it's opposite a bigger angle, right? And we found 22.5. Because 64 is more than double what 26 is, right? So this guy should be more than double what 11 is. Does that make sense? Yeah. So that's a pretty good answer. Okay? 35. Rewrite 75 degrees in radian measure. 35 degrees. How do I do that? No, we don't have 75 degrees in your chart. Darn. Yep, the conversion is either, for these two, either 180 over pi or pi over 180. And we have to decide which one we're going to use. Okay? And it depends on which unit they give us. So if it's 75 degrees, I'm going to do 75 degrees over 1. Okay? What do I want to put on the bottom so that it crosses out? 180 has to go on the bottom so that this degree will cancel with this degree, and then pi is on the top. Okay? And then we reduce down as far as we can get, but we never get decimals, right? Because we're already in fractions. So 5 and 12, you divided by, what did you divide by? 15? Divide by 15.
Yeah,
15? Yeah, if you divide by 15, 75 divided by 15 is 5, and 180 divided by 15 is 12. So this is 5 pi over 12. That's what it is in radians. 5 pi over 12. Yep, we divided by 15 on the 75 and the 8 and the 180. 5 pi over 12. Yep. Now, what if that was negative 75? How is that different? Your answer is just negative. Yep, the negative just tags along. Okay, 36. Rewrite 3 pi over 4 as a degree measure. Yep, this time you're going to multiply by 180 degrees over pi because you want the pi's to go away. Okay, and then what else will reduce? 4 and 180, 4 will become 1. 180 will become 45, you said? Okay, so we have 3 and we have 45, and on the bottom we just have 1. So 3 times 45? 135 degrees. Okay, now that one you do have in your unit circle. Do you want to check it? Look at 135 degrees. Make sure it's 3 pi over 4.
Yep.
Yep. Okay? Good?
Yep.
Yep. All right, on 37, I take it easy on you. I just say find one angle that is coterminal with 590, which basically means what's an angle that's in the same spot? You can add or subtract 360. Most of the time it was like find one positive and one negative, right? Okay? 360 multiple, yeah, 360 multiple times. Name an angle that is coterminal with 590. Which one do you want to do? You want to add 360?
I subtract.
You subtracted? Okay, so 590 minus 360 is the same thing as 230 degrees. Okay, so on your unit circle, you don't have to draw this. Where will 230 live? Just for practice.
In that third one.
In the third quadrant. So this is where 230 is. 590 will look like this. Right? It'll just be an extra one around. You don't have to draw all that. But 230 is the same thing as 590. They will all be in the same spot. Yeah?
Yeah.
Beautiful. Okay, find the exact value of sine of 240. That means don't plug it into your calculator and give me a decimal. I want the exact value. No decimals. No decimals.
Look at your circle.
You look at your circle thingy. Okay, so 240 degrees is in the third quadrant. If 230 is in the third quadrant, 240 is the same thing. What? And sine is the y-coordinate, so it's negative square root of 3 over 2 is the y-coordinate at 240. That's the answer. Easy. Gosh, trig is so easy, right?
I love it.
You love it. Hold on to that thought for 2 years when you take trig. Okay? No decimals. Negative. Square root of 3 over 2. I will give you a fresh unit circle. What I'm going to do is, I actually haven't printed off, but I don't know if they're on my desk. I will actually give you a whole sheet of paper to use on your test besides this packet. A whole sheet of paper that has this at the bottom and an empirical, well, no, actually it has this on the back side, and on the front side is an empirical, like the bell curve thing. So this is blown up even bigger on one side of the sheet of paper, and on the other side is the bell curve. I'll give those to you maybe tomorrow or something. So, okay, I think they're printed. They're maybe in the library. I don't remember. I printed them. Okay, one more, last one, 39. Find the exact values. Oh my gosh, this one's a long one. Find the exact values of the 6 trig functions of theta. What are the 6 trig functions, by the way?
Sine, no sine.
Hold on, just wait. Oh, no. You know what I'm going to do? I'm going to do one better. Okay, I've got a lot of room. Hold on just a second. Okay.
Oh, where did it go? Okay. You have a stamp that says it.
You're going to love it. You're going to love it. I got to find a good color.
Yeah, but we still have to write it, so.
But I'm going to use, what color shade? Pink. I don't know where my pink is. I don't have pink. I don't know where my pink is. Whatever. We'll do blue. We'll do blue. Okay. Tell Tanner Olson that I used his gift that he gave me. Here you go.
Oh my god, there's a lot.
Oh man, this is going to be awesome. Okay. All right, here you go. Ready? I'll put them over here. Boom.
Oh my god.
Look at that. Isn't that awesome? I told him at the beginning of the year I wanted to find a stamp that did that because I was tired of writing it over and over and over again. And there's actually enough room on this paper for me to do it. So there you go. Yeah, so exciting. No, it doesn't take very long.
Less time than it takes to write it all.
Yeah, less time than it takes to write it all. Okay, so there we go. Sine, cosine, tangent, cosecant, secant, cotangent, and they go with each other, right? Sine goes with cosecant, cosine goes with secant, etc., etc. Okay, now, they give me the point -3, 4. How do I do that? Mark it on the graph. -3, 4. Right here, yep. This is the point -3, 4. So I'm going to, then what? Draw a line. That line. And then what? Draw another line, because we make bow ties, not hourglasses, right? Here's my 90 degrees. Okay, -3, and this guy is 4, and then Kelsey's been saying it over and over again. A squared plus B squared equals C squared. Okay, so A, which side is side C, by the way? The hypotenuse, what we're trying to find. So we're going to put it as C squared over here. Okay, A is -3, and 4. Okay, what is -3 squared? Just 9. Just 9. 4 squared is 16. C squared, so 25 equals C squared, and it's another 5, 4, 3, or 3, 4, 5. So this is good, right here. It's a -3, 4, 5. Yep, 3, 4, 5. That's a special one. Okay. All right. So where does our angle theta live? Right there. Right there. Right there. Okay. Sine. So again, SOHCAHTOA. SOHCAHTOA. Okay. Sine is opposite. What's opposite this angle? 4. Hypotenuse is 5. Cosine. Adjacent. What's adjacent? -3. Make sure you keep the negative with it. Hypotenuse is 5. Tangent. Opposite. 4. Adjacent. 4 over -3. Okay, now let's flip them all. 5 over 4. -5 over 3. We've talked about that negative before, haven't we? Like you can pull them off the front. That's what I usually do. So this is -3 over 4. Yeah? Good? Perfect. Shall we stop?
Yes.
Let's stop. Okay.